All right, folks. So we are on the part number 4, or the third step of solving trusses, where we're going to look at forces in the X and Y direction in order to solve for the forces at the pin. In our earlier moments step, we solved for the force at the roller away from the pin using the applied forces and the roller forces. Now we're going to look at the forces at the pin. Okay. Very, very critical that you listen and you understand this next point because it's really important. Every step requires you to know what step you're in and apply only that step because they're all different from each other. All right. So then the next step is that we're going to use X and Y forces. The sum of forces in the X, Y direction equals 0, and the sum of forces in the X direction equals 0 to solve for the RF forces at the pin. In bold, exclamation points. The right-hand rule no longer applies. You're not solving for moments anymore. So do not look at negatives and positives from this step. If you have to, cut yourself out a piece of paper and cover it over. Because if you start looking there, you're going to confuse yourself because we're not looking at positives and negatives. Let me give you an example. This right here was a positive moment because it was trying to go that way around the pin. But in terms of Y, that is a negative Y. Okay, so you can't mix up the two. We are now looking at what directions forces are going in the X and Y direction. Okay, now if you want to, you can update your free body diagram to show that we found out that this force is going up. We found it out, and we found out that it is 95. Okay, pounds or whatever type of force it is we're dealing with. Now, once we've done that, we can start figuring things out. Let's start with the sum of forces in the Y direction equals 0. Sum of forces in the Y direction equals 0. Let's take a look at the forces that we have in the Y direction. We have a 95-pound force going upwards. That is a positive Y. Then we have this force going downward in a negative Y. So that's a negative plus the one that we don't know, equals 0. Okay, so to get RF dy by itself, is going to equal, it's going to be a positive 220 because we add 220 to each side, minus 95 because we're going to subtract 95 from each side. So it's going to be 220 minus 95 will be 105. Correct? No, 115. No, 125. Sorry. It's late in my day. All right. So we have a force that is 125. So we found out that our force over here is positive. So RF dy is going upwards. It is a 125-pound force going upward. Again, stop thinking about moments because this is different, right? We're not applying the right-hand rule anymore. All we're looking is what direction in the X and Y are we going. Now, I always like to check, right? These will balance out. So if I've got 95 going that way and 220 going that way, then whatever this plus this adds up to are both going up will be counteracted by that one going down. All right, so it kind of makes sense when you think about it. All right, now we're going to do the sum of all forces in the X direction equals 0. Now this one is a no-brainer, and here's why. we had 3 forces in the y direction, but if you take a look at the x direction, how many forces do we have? We only have 2. We have 1 here and 1 right here. So really, if you think about it, this plus this equals 0. If 75 is going to the left here, it has to be going to the right here. Okay, so we have a negative 75 because it's negative x direction. Stop thinking moments. Plus RF dx equals 0. RF dx equals 75. And it's going to the right, positive x. So RF dx is 75 going right. All right, cool. So we have figured out that step. Let's go ahead and take a look at the other ones. Now I'm going to make you a deal for these. If you write the static equilibrium equation and say the sum of all forces in the y direction equals 0 and the sum of all forces in the x direction equals 0, I'm going to let you just write down what it is. So let me give you an example. RF AY. Now, I'm going to look up here because RFCY we found out was 57.14 and it was going upwards, which means, again, I'm ignoring moments. It's going positive Y. That means that RFAY is going to be 57.14 and it is going to be going down negative. Okay. So I'm also okay with you doing the other one. Your x, we know, is the opposite of that because there's only 2 forces in the x direction, which means that my RFAX must be going, since that's a positive, it must be a negative opposite. So I'll let you do this shortcut if there's only 2 forces in the direction. Okay, so that means that my RFAX was 100 going the other way, and that my RFAY was 57.14 going that way. Okay, now again, your numbers are different, but the concept's the same. And if you look at your summary box, you're going to have opposite and equal and opposite and equal. Whoops, I put that 57.14 for my RFAY or RFCY. Oh, it's this one. Whoops. That's my dog. My RFA in the Y direction was going down. Negative. Whoops. Okay. So that's why it's good to put your eyes on it and check it and see if it's opposite and equal. All right. The last one. Again, we only have 2 forces in the Y direction and 2 forces in the X direction. And we found out that this pin was going that way with a force of 350. Okay, in an earlier step. So now we know that if the sum of all forces in the Y direction equals 0, that we have this negative 150. So RFBY must be, because that's negative Y, this must be positive Y, and it's equal but opposite. 150 going positive. My sum of forces in the X direction means that I knew that this was 350 going positive. So my RF at B of X up here will be equal but opposite. Okay. So we're then going to update our box. So RFBX we found out was 350 going that way, and my RFBY was 150 going that way. And again, you'll always have in this summary box two things, or it will add up. All your Y's will add up to 0, and all your X's will add up to 0. Okay, so there we are with our, I hope that I was showing this earlier. If I didn't have that in the camera, then we just figured it out, right? So now we can update, although we've got our summary box done, but we can update this if we want. Say, okay, I know that one's going that way with 350. And I know that this is going that way with 150. Cool. Our next step will be method of joints, where we're going to get away from the external forces on the truss, and we're going to deal with the internal forces on the truss. All right, enjoy.